All right. So, perfect. All right. So yesterday, we were analyzing if mass had effect on the transfer of energy, and our end answer was a yes and a no. It just depended if it was sliding or rolling. Correct? All right. So today's question we're going to try to solve is how do humans get energy? All right. I don't think it was this class that asked that question. I think it was my 9th period class that asked that question. But how do you think humans get energy? Eat? Eat gives us food. Or, oh my, I don't know what I just said. Eating gives us energy.
Sleeping.
Sleeping gives us energy? Interesting. Well, we'll have to find out. Yeah. Oxygen gives us energy. I'm gonna write these down. We got some good answers. So we said oxygen so far. We said sleep. And we said food. And food, water, food dash water, or food dash drink, I should say. Okay. Guess we're gonna have to find out. So I got a few slides queued up. Now, what we're going to be talking about today is the conservation of energy. I'm going to kind of go through those pretty quick because we already got that down, right? Energy is just conserved, right? So we kind of got that down. I'm going to go through those pretty of energy and how we get our energy, all right? So we're going to go through this pretty quick. Won't take too long. And then I got a little activity we're going to try out. Analyzing your favorite snack. That'd be pretty cool if we could like bring in our favorite snack, but COVID and everything, probably not the best idea. I wish though. It'd be pretty cool. All right. So the conservation of energy. All right. Energy cannot be created or destroyed. Got that? Check. We feel good on that? Yeah. So if we look at this, while energy cannot be created or destroyed, it can be transformed. Okay? So the example we did the other day, well, we did a skateboarding, right? So when you're halfway down the hill, kinetic increases, potential decreased. And when you're right above the bottom of the ground, that's where your kinetic energy is at its max. Right? We feel good on that? Just kind of a review. All right. So when a cart is sitting at the top of a hill, the mechanical energy is based on the potential energy. So yesterday we did a little skateboarding activity, right? A little skateboarding, and I told you to calculate the energy at A. B was like right there, and C was down there. You guys remember that problem? Okay. So A, all you had to do was the mass of the person times gravity times the height. And that solved our potential energy. But what that also did was solve for our mechanical energy, because when he's at the very top, he's not moving. So what's your kinetic energy when you're not moving? It's a big zero. Right? That's how you would have done that. Right? As the cart starts to travel down the hill, it's transformed into kinetic energy. Okay? So you start to build up some kinetics, and by the time you reach the very bottom, how much kinetic energy do you have? Percentage-wise, how much kinetic energy? Probably 100%, right? At the very bottom, you're 100% kinetic. Because when something's on the ground, how much potential energy does it have? 0, right? The height is 0. So when the height is 0, no potential energy. And there's an example of it. Okay? I think we feel good on that. Okay? And then if there's no outside forces are being used, like a conveyor belt, would the roller coaster be able to go up the second hill? So, would this roller coaster be able to go up that hill? Landon.
No.
What?
Well, wait. Which one's the second hill? The bigger one or the smaller one?
Well, this would be the first one. The second smaller one would be the second one.
Oh yeah,
You would?
yeah.
Why?
Because like when you're going down the big hill, I guess he has like more momentum, so it just takes him up the second one.
Do we agree with that? That was pretty good. That was pretty good. I would have to agree. You would be able to go over that second hill. Now, would you actually, let's say that those are the same height. Would you be able to go over that hill if it's the exact same height? Devin?
No.
No, why? You're exactly right. So if you start at the very, very top, you will reach the very, very top of that. But that's the furthest you're going to get. You're not going to go over the crest there. You're going to stop at that very top. Little tricky question. That's if no other forces were acting on it. Interesting. Interesting. Okay. So, we talked about elastic kinetic energy, or elastic potential energy, I should say. Right? So, if energy must be conserved, why didn't the balls from 1 meter in your lab bounce back to 1 meter? Why didn't they bounce back to 1 meter? All right, we did this lab the other day. If energy must be conserved within a system, why did the balls bounce from 1 meter back up to 1 meter? Where'd the energy go? Yeah.
Did it go into the floor?
Some went into the floor, yes. Where else? Yeah.
Why did some also go into the air?
Some went into the air. So some energy hit the floor, bounced back. That energy caused a little bit of friction. Friction is heat. Heat is energy. So some we lost to the floor, some we lost to the air. How? What energy do we lose? How, like when dropping a ball, what's fighting against the ball? What's air resistance, right? Air resistance is our energy. We're losing out on it. All right. So as the ball continues to fall, we're losing energy out of the ball. All right. And that's saying the same thing. Okay. Saying the same thing. Okay. So when thinking about energy, we just said one form of energy, thermal. Before we go on too much further, what other types of energy can you think of? Devin? Mechanical? Okay, so we got our mechanical, potential, and kinetic. Okay, what other forms of energy do we have? Yeah.
Nuclear?
Whoa, man. We just talked about that a few few weeks ago. Nuclear energy. Yeah. Oh, okay. Let's put that in the category. We're gonna put that in the. That's kind of thermal, but we'll put it in like electrical. Would that be good? Electrical energy or currents, right? Current runs from, let's say, like a phone that might be being used to through like maybe ear pods or something like that. You know, that's a current. Yeah, another one.
There's elastic potential energy and gravitational potential energy.
Okay, so we got elastic potential energy, gravitational potential energy. Okay. Let's see. All right. First one, we covered nuclear. We know nuclear, right? We kind of talked about nuclear energy. Type of potential energy stored by forces holding together subatomic particles. Okay, we kind of covered that, right? Holding together subatomic particles. We have fission and fusion. Okay. Energy can be released through splitting or joining of nuclei. So that's how we got energy, right? You guys are very, very quiet today. All right, so we got nuclear energy. Now, Einstein has this equation. E equals mc squared. Okay. Now, somebody asked, it was this class, I'm pretty sure. Somebody asked the question, if an object doesn't have mass, does it have energy? An object doesn't have mass, does it have energy? What do you guys think? No? No mass, no energy? Do we agree with that? How many people say no? No mass, no energy. How many people say yes? I should definitely give bonus points to the people who just participated. Man. Interesting. Interesting. We gotta increase our participation a little bit. Gotta get awake or something. All right. Now, this is a little interesting. So energy is equal to, if we look at Einstein's equation, if the mass is 0, energy is going to be 0, right? The tricky thing here is there's a few other equations that we have. Well, okay. Well, we'll make it straightforward. These equations. So, in the future, very short future, we're going to be learning at least this one. It's a wave, right? We're going to be talking about waves, all right? Where if c is the speed of light, pretty fast, right? So a wave has wavelengths and frequencies. Have you guys learned that before? Waves have wavelengths and frequencies. So this right here is the wavelength. This is the frequency. Okay? So light has a frequency, correct? So we know, and down here, this is a frequency. And h is always 6 times 10 to the negative 34th. That's just always what it is. So if we say light always has a frequency, light's always going to have energy. Can we say light has energy? Does light have mass? No. So does something have to have mass to have energy? No, it does not. And light's the only example I can think of. Pretty crazy. Crazy stuff. So nuclear energy. Electrical. This is pretty straightforward. It's flowing through our electrons. All right. Devin got that one. Electrical. Light energy. Oh, my picture got in the way. It's a pretty cool picture. We're actually going to eventually get to light energy in the electromagnetic spectrum. It's super, super cool. That's actually probably closer to the end of the year. Well, we are at the end of the year. Holy smokes. That's pretty crazy. Already in fourth quarter. Mind blowing. So we'll probably get here, I guess, semi-soon. Okay. Light energy. Traveling through prisms. Super cool. Super cool. Then how do we get energy? We said food. We said drinks. We said all of food, drinks, and sleep. Oxygen. Okay? Our main source is food, right? We get food. And food gets its plants through a process called photosynthesis. Right? You guys have heard that. Just checking. Photosynthesis. All right? And this is the process over here. All right? So the sunlight. And you're going to learn all about this next year. Sunlight creates chloroplast. All right? Sunlight, water, and soil creates energy. And that energy releases CO2 and water, and then we get more food. And the process just keeps continuing. We keep getting energy and energy and energy out of plants, and that plants give energy to chickens, and then chickens give energy to us. Do we give off energy? What do we give energy to?
Can't we give it back to the planet?
We do, right? We do. We create more and more. It's kind of like the circle of life, and it's brilliant song, Circle of Life. Okay? Now, what I want you guys to do is I want you guys to look up your favorite snack. Okay? So where do humans get our food? All right? We get energy from the foods that we eat. This energy is often measured in calories. Okay? Calories. 1 calorie is equal to, oh, this is interesting. What's the unit for energy? Joules. Very good. So 1 calorie is equal to 4,186 joules. Okay? 1 calorie is equal to 4,186 joules. Okay? On average, a teenage girl needs to consume about 1,800 calories a day, whereas teenage boys need to consume 2,200 calories a day. All right? So, what I want you guys to do is research your favorite snack. Not like a meal, just a snack. Okay? And then you're going to see how many calories are in 1 serving of that, and calculate how many joules are in that favorite snack, and how many joules of energy you need to consume of that snack each day. Okay? So you guys can do that on your phone. You can do that on a computer. It's just a half sheet of paper. It's not a lot. It's interesting. Definitely interesting. See our answers? Yeah. How many joules?
Yeah.
Ooh. That's actually one of your questions. But I would say it's different for males and females. I'd say around 9 million. 9 to 10 million. Yeah, a day.
Right.
Do you have a preference on color? No? Alright, you're just getting the top one. Do you have a preference on color? Really?
That's
Alright, you're getting the top one. That's you have a preference on color. No? You're just getting the top one. Definitely have to, definitely. Absolutely. There you go. Oh, yeah, we're on the street now. We're on the street. There we go. Oh, we're on Blue Street right now. Oh, there we go. Yep. All right. Blue as well. All right. Good. Blue? I'm gonna run out of blues. Nothing wrong with that. Blue as well. There you go. Wow, we're just going on blue here. I thought for sure you were gonna be switched
I have
up
so
on me.
much power.
Ooh. I like it.
That's a power.
There you go. What color are you feeling? Blue. You're feeling blue or you just, that's it?
Why not?
Yeah, all right. I got orange. My red is very dark and it's hard to read off of when I think copies. There we go. All right, so I want you guys to look up your favorite kind of snack. Oh my. Just means you don't have to do it. You just get like extra credit for doing it. Just kidding. What color would you like? I pick, my favorite color is green, so I'm giving you green. All right. Whoa. Favorite snack. Might be my go-to. Pretty good. Let's see. Wow, this website just tells you the jewels. That's pretty cool. Wow, this website's fascinating. So if I ate one serving of Pringles, I would have to walk 42 minutes to burn off the calories. Oh my gosh. Ooh. Okay. Yowzers.
We could do 15 minutes.
So if I ate a whole can,
You have to swim for 75 minutes. That sounds fun.
I would have to walk for 4 hours to burn off
That's crazy.
my calories. Oh man, I gotta switch my ways. I gotta find a new snack. I don't have to do so much walking. Oh, or cycling. I do like riding a bike.
Yeah, you like riding it for like good 2 hours, 10 minutes.
Yeah. Oof, that's brutal.
What's that website name?
Calorie King.
Oh,
Calorie King.
Mr. Bowers.
Yeah.
You turn this in.
Yeah, I'll take it. Hey. Get it all done. You need to have 3,000. Oh, you're eating healthy. 3,000 servings. 10. Wow, that's a big difference. So mine. One serving. So in one serving, I had 150.
I'm gonna hear more.
Thank you.
But like times 2 for each chocolate. It's just.
Mr. Bowers.
Yes. Perfect. You can put it right there. Thank you.
I got you.
Yeah, because we inspired one another. And you know what?
Jules. On average, how many joules of energy do we need to consume a day? So I need to consume
That's not even.
I'll go on.
209. So I need to consume 9,209,200 joules. Okay, so one serving of Pringles doesn't give me that much energy. Number 5, based on your answers of 3 or 4, how many servings would you need to eat in one day if that was my only source? So you're going to take that number divided by 627, 900. Oh man!
Mr. Bowers, you want 19 million joules in one day? That's how fun. There's a burger in Texas that like it's a 2-pound burger,
Oh,
4,556 calories.
oh my gosh!
That's like
What in the world? So if you do 9,209,200 divided by 627,900, that's equal to 15 servings. So how many calories do I need to eat? Let's do that. 9,209. All right. So I need 15 servings.
Yeah, it's been I don't even know what we're talking about.
How many joules are in one serving?
I have to walk an hour. I can stir one. I have to walk.
So looking at mine, I need 15 servings of Pringles to get enough energy for the day.
400.
with that 15 servings, I need to walk 626 minutes a day.
Wait, is this
I just gotta start now if I'm doing 626 minutes.
So, like, let's say the difference between like meat and vegetables, if you want to do vegetables.
Which
Okay,
one?
so let's say like you did not eat calories, but
So it all walks out. So like the meat has more protein. So the protein helps you build like more muscle. It helps you in other ways, but just based on energy, it's just calories.
You wanna walk that long?
Oh,
There. 1,370.
I gotta start jogging so I can eat a Pringle later.
Like a day, you got to walk it.
All right, so if you're still working, that's fantastic, fantastic. When you're done, I'll take it up here. But when looking at this, if you look at your serving size, to do your conversion, do you want to use an electric one? The electric one's worth a lot better. You got one on both sides. That one's golden. This one's kind of like average, you know. That one's gold. The boss stitch. It's really, really good. So, wow, that was quick. See, I told you it was a good one. So, if you multiply these two numbers, that's how many joules of energy is in one serving. Number 4, all you had to do is multiply how many calories you all need times 4,186, and that's what I got. Ladies might have had a different number. Okay, and then the final is you divide whatever your answer for number 4 was, divided by your answer from number 3, and that's how many servings you would get. Okay. And that's where we got our energy. All right. And apparently I have to walk 10 hours, 10 and a half hours. That's a lot of walking. A lot of walking. Wow, good job, guys. Just want to see. Ooh, Cheez-Its. 15 servings of Cheez-Its. 5 servings of Oreo Blizzards from Dairy Queen. Nice. That make 5. So I could eat 5 of those. Get enough energy for the day. 18 granola bars. That's a decent amount of food. 12 servings of Pringles. Sour cream Pringles. Those are good. 7 servings of a bagel. Man, I could eat like a dozen bagels in a day. Funyuns. 16 Funyuns. Do that. Wow, fruit snacks. 47. You can have a lot of fruit snacks. That might be my new go-to snack. You can have 47 fruit snacks in a day. 6 ramen noodles. Man. Cheez-Its again. Cheez-Its. Fruit snacks. Ooh, 13 servings. Interesting. Different kinds of fruit snacks. Spicy Cheetos. 14 servings. Oreos. 27 servings. Marshmallow Frosted Flakes. 9 2-cup servings. Wow, that's pretty small. So like 9 bowls of cereal. But when you think about it, that's actually kind of a lot of food. Normally for breakfast, you only have 1 bowl. That means 4 bowls of cereal for lunch and 4 for dinner. That sounds like a lot, actually. Really? Oh my gosh. Let's see what we got. Hold on. Let's see. You need 13. Oh, goldfish. 13 servings. I wonder how many goldfish are in this serving. Yeah. Ooh, fudge pudding, 25 servings. I would definitely do 25 servings of fudge pudding.
55 goldfish in this.
Okay, so 55, and you can have 13 of those. So 55. Okay, you can have over 700 goldfish. Yeah, absolutely. That's Skittles, 16 servings.
I don't know.
9 servings of pretzels. That's kind of shocking. Oh, I see. Whoa. You can have 3,000 servings of strawberries.
They're 4 calories.
That is wild.
It's only 1 strawberry.
3,000 strawberries. That's so healthy. I wish I liked strawberries now. Honestly, I'm gonna make myself. What?
You don't like strawberries?
Not my favorite, but since they're 4 calories, you can have 3,000 of them a day. They might be my favorite now.
What's your favorite fruit?
Ooh. Just eating it or like mixed with something? Like I love watermelon. I love just sitting there and just eating some watermelon. I like apples. I like pineapple. Cantaloupe. I like a lot of fruit. Mixed with something. I don't know. That's tricky. I do like orange juice. I'm not a big orange fan though. But anyway, guys, you got about a minute left. So if you guys want to pack up your stuff, you can do so. Yes. I do. Like, I don't want to eat a lot of them, but I do like grapes.
I found this thing over the summer, and I would eat the day before the taste, and it's like
Really? Huh. All good? Interesting. That does sound pretty good. So what? Yes, to get the report cards. Yep.
Yeah, because one of my friends.
Yeah, they didn't really go over that on the announcement, so they decided to do it between 2 and 3. Yep. All right. That was cool.
I watched that Justice League.
Did you? How was it?
It was good. Although it's 4 hours long.
Is it really? 4 hour long?
Yeah.
Wow. That's really long. Man, I gotta keep stepping. I gotta get that. Instead of having, like, I think the serving was 15 chips. Might only have to be allowed to have like 2 chips. Unless I keep walking. No? All right, guys, just a heads up. Don't forget to go to your homeroom. All right, you guys are going to homeroom. Get your report cards. Hope you guys have a fantastic weekend.
I don't know about.
Is there a way to see?
It should be on your
Progress.
progress report. Got a lot of things here. Let's see. When? Well,
Wait, you have her?
No.
Randy White, can you please come down to the receptionist desk? And also Logan Nesbitt.
Great. Yeah. Yeah. You guys had a short walk.
Max Gutman, would you come to the attendance office, please?
Hello.
Hello.
What's your name?
Ella.
Hello.
Wolfer.
There's this. And
Thank you.
hello.
Hi.
You got it? You have a WP?
WIE.
Okay. There you go.
Thank you.
Hello. Okay, you're good to go. Thank you. Hello. How are you? What's your name? Brooklyn. What's your last name?
Wicket.
You're probably gonna be over here. Hi. There you see mine. You're welcome. Let's see. Oh, you got the WEP. Who put their shoes in? Definitely. Oh, there you go.
Thank you.
Can I get water? Hello.
Hello.
Perfect. Let's see.
This is a reminder to students to please make sure to swing through your homeroom on the way to third period to pick up your report cards. Once again, students, reminder to swing through homeroom at this time on your way to third period
Hello.
to pick up your report cards. Thank you.
There's that, and you have any? You good. There you go. Yep. Wilson. You good. There's this, and here's your.
Can I go use the restroom?
Yes, go ahead. Okay, yeah. These, and here's your. There you go. Yep. Hello. Hello. What's your last name?
Getting right.
Go ahead.
Hey, John.
There you go. Have a good day. Wow, we're rocking it right now. You guys already went to homeroom?
Yeah,
You guys are speedy
Yeah.
quick.
I did first period.
Oh, did you?
Because, yeah, prior,
Yeah. All right. Hello. Man, I saw two papers. Was like, there you go. Have a great day.
Is this the sun?
It is the sun. Sweet.
oh,
Sunshine. All right.
How many of those trades look at time?
Barely made the cutoff for it.
What? Dude, AB Spanish. She is screwing me over. The energy worker is screwing me over. What's your last name?
Last quarter.
There you go.
On every AP classroom assignment. Dude, my AP physics teacher just like, my AP.
Yeah.
Funny Nathan,
She's really
that
good.
really cool.
This part she like starts. I'm not taking my shoes on my desk.
Some kids always wear sandals or Crocs from that. You're not allowed to, so I was hello, what's your last name? Whoa. Landed? There you go.
Really did not want. All right.
Now,
Certified Nurses Day.
Certified Nurses.
Oh.
can we do something as a class that I feel like that will bring us all together? We create a March Madness.
Oh.
Yeah.
That's a good idea.
And we all make our own brackets.
That's a good idea.
Definitely interesting.
It will take maybe 10 minutes out of class today. If that.
I got too much I gotta go over today.
This last day.
Yeah.
I got him right here.
Wait,
What's your last name?
Oh!
Yeah.
They're both in 89.
You're good, you're good. Have a great day. All right. All right, guys, let's find our seats.
I've been here every day.
It was definitely interesting last year because I had a bunch of seniors. And it was my very first year here.
Oh.
And they were just kind of like, we don't really care about homeroom. I come in and I'm like pumped to go, you know.
Mr. Bowers, this doesn't make any sense.
All right,
It still counts as absent if you're quarantined.
Seriously?
let's take attendance. Jennifer, Landon, Tommy,
But it says
Here.
optional.
Coy,
Yeah.
Stone Gray, Andrew, Keegan, Owen, Dylan, Josh, Cole,
Here.
Nathan, Nick, Caden, Taylor, Andrew, Caden, Jake, I almost said James,
Oh, you said James.
Jake, Brady.
Here.
There we go. So, guys, I found out some bad news today.
Oh, is it about the AP exam?
No.
It doesn't matter.
So, I found out that in my entire day, I'm allowed to have, well, Google tells me around 2,200 calories, right? And my favorite snack is a Pringle. So if I had 15 servings of Pringles, that would give me enough energy through calories for the day, right?
Yeah.
Now, to burn off those calories, I would have to walk for 626 minutes. More 10 and a half hours I have to walk to burn off those Pringles.
Oh.
Here, I'll do it on a 20 into a quarter pound of dynamite.
You burn calories when you're sleeping though.
That's true.
Why'd you look at me?
So if we take those out, it's probably only like 6 or 7 hours in.
That's a little better.
I know I'm not.
So I gotta stop eating Pringles is what they're trying to tell me. A little interesting.
Like one container.
So what? Who is wrong? Is it you? Look at nail fell out of the ceiling. I was like,
All right.
Oh, yeah.